All right, we are basically asked to multiply these two rational expressions, but we would rather simplify first because this would be a lot of work to multiply all these terms out. But we can't just cancel, say, this x and this x because it's being added or subtracted. You can only cancel common factors, that is, things that are being multiplied. So I'm going to try to rewrite each of these polynomials into factors. So on our left side here, if I can rewrite that into factors, and I can rewrite the denominator into factors, if any of these are common, I can cancel. In fact, way over here, if any of these, if I can get it rewritten in this form, everything's being multiplied. If this is identical to that, I can cancel it. Okay, so we're going to try to do that. Looking first at this one here, I want the factors of 42 that will give me a sum of positive 13. And to be real systematic, if you already know the answer, you just plop it in there. But 42 would be 1 and 42, 2 and 21, 3 goes in there, 18, 3 times 8, 24, 14, 3 times 14, 4 won't work because that's an odd number, 5 doesn't work, 6 goes in, double this, cut that in half, 6 times 7. Okay, and this would give me a sum of 13. So that one becomes x plus 6, x plus 7, and we've managed to factor the first trinomial. Turning our attention to the denominator, I want all the factors of negative 35. Slide this up a little. And I want to figure out what will give me a difference of positive 2. So for negative 35, we have 1 and 35. 2 won't work. 3 won't work. 4, 5 times 7. So if we have a negative 5, positive 7, that will give us a difference of positive 2. So we have x minus 5, x plus 7. All right. Turning our attention to the right-hand side. For the factors of negative 5, it's going to be a short list. 1 times 5, and I want a difference of negative 4, so it must be negative 5, positive 1. That gives us x plus 1, x minus 5, and finally turning our attention to the denominator here, all the factors of negative 14 would be 1 and 14, 2 and 7, and to find a difference of positive 5, positive 7, negative 2 will do the trick. So x minus 2, x plus 5. Now we have everything being multiplied, each set of parentheses is being multiplied. So I'm allowed to cancel a set of parentheses if they match up exactly. So I have a x plus 5, but nothing to match it with, the x minus 2, x plus 7 and x plus 7, so they cancel. X minus 5 and x minus 5, they cancel, and you simply record what's left. We have x plus 6 in parentheses, and we have x plus 1 all over top of x minus 2 and x plus 5. I'm perfectly happy with the answer in that format. Even though it says multiply, well, it's ready to multiply, but we certainly simplified it, and this answer should be fine. If you're doing a multiple choice test and that's not one of the selections, then you would simply multiply everything up top using, some people say FOIL. X times x would be, let's just see what that would turn into. Usually that's a perfectly fine answer, but again, if it was a multiple choice test and that wasn't available, you'd have to rearrange this. So x times x will be x squared plus 1x plus 6x plus 6. So for your numerator, you would get x squared plus 7x plus 6. And your denominator, that would be x squared. I'm going to do this one more in my head. X squared plus 5x minus 2x would be plus 3x, and then minus 10. So this means the same as that, but again, usually they're perfectly happy with that answer.